بسم الله الرحمن الرحيم أبنائي طلبة وطالبات السات أهلا ومرحبا بكم. Hello everyone, welcome to Teach Me Sat. My name is Bassem Khalid and we are doing arithmetic basics. In our lesson today we will learn how to apply laws of exponents, the plug-in technique and absolute values. Alright. Laws of exponents, the powers. The first law would be if I have a to the power m times a to the power n, the rule says it should equal a to the power m plus n, which means we have to add the power. So if I have a to the power m multiplied by a to the power n, the answer is a to the power m plus n. So we add the powers. This is called the product of powers. Simple example for this one would be if I have 2 power 3 multiplied by 2 power 5. If we apply the rule here, we should add the powers. So I have 2, 3 plus 5. We add the powers. So it will be 2 to the power of 8, and if you write this for short form, it will be 256. The second rule will be quotient of powers. So the second one will be in case of division. If I have a to the power m divide a to the power n, this is called quotient. Quotient means division. Here we should subtract, not add. We subtract in this one. So we subtract the powers. If I have a power m over a power n, it should equal a to the power m minus n. Example for this one would be if I have 2 power 7 over 2 power 4. In this case, we subtract the power. It will be 2 to the power of 7 minus 4. So the answer will be 2 to the power 3. And for short, it will be 8. The third one will be the power of a power. What's the power of a power? If I have a to the power m, all raised to another power which is n, should equal a to the power m n, which means I remove the bracket and I multiply m and n. So if I have a power m here in the bracket, all raised to the power n, you simply remove the bracket, as you can see here on the right side, and you multiply m by n. An example for this one, let's say I have 2 power 3 all power 5. If I want to simplify this, we apply this rule. So I multiply 3 and 5. So it will be 2, 3 times 5, 3 times 5. The answer is 2 to the 15. Now we can work this on the calculator. I already did it before, so I'm going to show you how to do it. So it's going to be 2 to the power 15. The answer is 32768. 32768. Now to the next rule, rule number 4, that would be power of a product. So if I have a product, it means I have something like this, a times b, this is called the product, all to the power m. This rule is called power of a product. In this case, we distribute the power over whatever I have inside the bracket. It means a will take the power m, and also b will take the same power m. So you can see here I removed the brackets and I've given A the power m and B the power m as well. Example for this one will be 2x all power 3. So I have 2 multiplied by x. 2 here is like A in the rule, and x would be B. M, the exponent, you can see it's 3. So I will distribute the exponent over the values we have in the brackets. So I have 2 power 3 and x power 3. So finally we have 8x cubed. Cubed means power 3. You can see that. Now to the next rules. The next rule, the next one would be power of a quotient. It means we have a quotient. We have a division. Let's say I have a over b. That's a division, quotient, all to the power m. So this is called the power of a quotient. The same thing we did in 4, we will do it here again. So I will give a the power m. I will divide it by b. That will also take the same power m. Simple example for this one would be if I have 2 power 7. So I'll write the 7 later. So if I have 2 over 3, for example, or power 3, this one will be 2 to the power 3 over 3 to the power 3. So I distribute the power here, this 3, I give it to the 2, and I give it also to the 3. So this one will be 8 over 27. The last rule is very simple one and very actually useful one. It says if I have a to the power of m equal a to the power of n, and this is very important. You can see here we have the same base. A is called the base in both sides, the left and the right. A to the power m equal a to the power n. In this case, and only in this case, we can cancel out the base, roughly like that, and the answer will be m equal n, and the powers will equal each other. Right? So you cancel the base only if the bases are the same and you have equal sign in the middle. Example for this one, let's say I have 2 power 3 equal 2 power x. The question says find x, find the value of x. So in this case I will apply the same rule here. You can see rule number 6. We have 2 to the power 3 equal 2 to the power x. So the first thing you check, you have the same base. Yes, we have the same base. We have equal in the middle. So I'll cross out 2 from both sides, and I'll just write 3 equal x, which means x equal 3. So x here equal 3. All right, move on to the next point, the absolute values. Now, the absolute sign is like 2 bars like this, right? This is called the absolute. Usually we have something inside a number or a variable. For example, if we have absolute 3, or maybe absolute negative 3, also it works. So the number inside can be also negative. Now, what's the value of absolute 3? It is 3. What's the value of absolute negative 3? Also 3. What about the negative? We cancel it out. So this is the idea of absolute. Absolute of any number, whether this number is positive or negative, like in this case, the answer is always positive. Remember this. The answer is always positive. All right, keep this in mind. Think of it as a washing machine. This is what I always say to my students. Think of absolute values as a washing machine. In this way, like the absolute is the washing machine. Now, if I put inside the washing machine clean cloth, like the positive number, it comes out clean, right? If I put dirty cloth, which is negative number, a negative number here will be the dirty cloth, it comes out what? Clean, positive, of course. So this is the idea of the absolute values. Regardless of the sign of the number you have in the absolute, between the absolute signs, positive or negative number, the answer is always positive in this case. Alright, you should keep this in mind. It's very useful idea, alright, a very useful concept. Now we move on to the problems. This is the first problem we have. The problems I'm going to work out in this video are from the Barron's book, the Leader in Test Preparation for SAT, of course. It's actually a very, very good reference, and I would like to recommend it to everyone. So the first problem we'll solve here, as you can see, it says if A is greater than 0, A is greater than 0, less than B, less than 1. Alright, it means A and B are some numbers between 0 and 1. Which of the following is true? The first given, we have 3 givens, you can see that. This is a multiple choice question. So the first given, it says A minus B is negative. The second one, A over AB, 1 over AB is positive. The third one, 1 over B minus 1 over A is positive. So basically what we have to do is to check each one of these 3 givens. In order for you to do this, you need to use a technique which is called the plug-in technique. It's a very useful technique, and it's simply a tool in SAT that we use to work out certain tricky problems. How do we do that? By simply assigning a value to the given variables. All right, it helps you track all the possibilities and just makes it a lot easier to working it out. So in this case, okay, we will imagine that we have a number line here. All right, and this is the 0 and this is the 1. According to the problem, A would be any value between 0 and 1, and B also between 0 and 1. There is a condition here. You can see that B is greater than A. So if you choose A to be here, B has to be greater than A. So to solve this one, we will use the plug-in technique. It's a very simple technique actually. You just assign a value for A. You say let A equal whatever value you want, any value between 0 and 1. I'm going to choose 0.1. You can choose anything else, it's okay. And for B, we will choose something greater than A. Let us choose 0.5. And then we will check each of the givens. We have the first one, A minus B. It should be, they say it should be negative. The second one, they say 1 over AB should be positive, and the third one they say 1 over B minus 1 over A should be as well positive. Alright, it's very simple. What you're gonna do here is just substitute. You're gonna substitute A and B, the values of A and B in each one of them. So here A is 0.1, B is 0.5, and you can see the answer would be negative 0.4. This is a negative answer, which means the first given is true. So this is true. A minus B, the answer will be negative, which is correct here. They say, is it negative? Yes, it is. All right. The second one, we do the same thing. So it's going to be 1 over A, which is 0.1, multiplied by B, which is 0.5. All right. We don't care about the value here. We just care about what? The sign. So this is going to be 0.05. You can see clearly the answer is what? Positive. That's right. It is positive. So that's also true. This one is positive as well. All right, the answer here was negative. The answer in the second one is positive, so the second one is true. Now the third one, we substitute also 1 over b minus 1 over a, so 1 over 0.5 minus 1 over 0.1. If you work this out on the calculator, I'm going to do it mentally, it's simple. So this one will be 2 minus 10. The answer will be negative 8. Negative. Is it negative, the third one here? Check number 3 here. Is it negative? No, they say it has to be positive. Is it positive? No, it's not. So this one is not true. It is false. So this is not true. So the only true givens here are 1 and 2. 1 and 2. So check the answers here. Which one says 1 and 2 only? This one, number 8 says 1. Number B says the second. C the third. D says 1 and 2. That's the one. 1 and 2. That's the one. So the answer is D. Alright, very simple and useful technique. And we're going to use this technique a lot actually in solving SAT problems. Now, to the second problem. It says if 7 to the power a multiplied by 7 to the power b equals 7 to the power c over 7 to the power d. They say what is d in terms of a, b, and c. It means we want to find d, and we want to find d equals what? Of course, in terms of a, b, and c. We want to know what's d. Alright, so if you check the problem here, it looks like what? Exponents. So we will use the laws of exponents. Alright, let's write the expression here. 7 power a multiplied by 7 power b equal, just copying the problem. Now we try to apply the rules and simplify the expression. For the first one, this is what? This is product of powers. 7a times 7b. This is rule number 1. So rule number 1 says if I have a product of powers, I simply do what? I add the powers. So this is going to be 7 to the power a plus b. The second one, this is the quotient rule, the second rule. So what do we do here? We subtract the powers. You can see that. Okay, that's rule number 2. Now, if you check here, this one, we can apply which rule here? I think number 6, right? The one that says a power m equal a power n, and you cross out a, so the answer will be m equal n, right? So number 6. You can see here we have the same base, 7 and 7. Powers are different, so you have the right in this case, and you have equal in the middle, of course. You have the right to cancel out the 7 and simply write the answer, which is a plus b equals c minus d. And there is one more step. I need d to be in the left hand side, so I'm going to move d to the other side. It will be positive d. Here it's negative, so it goes to the other side with a positive sign. And at the same time, I'm going to move the b to the right side and a as well. So on the right side, I have c minus a minus b. So this is the final expression I get. Now let's check the choices that we have. Do we have this choice here? Check the answers. A, B. Yeah, it's clear. It's B. Very clear. Yeah, it is B. So the answer is B. All right. Good. Now moving on to the next problem. All right. This one about the prime numbers. Great. It says if P and Q are primes greater than 2, which of the following must be true? P plus Q is even. P times Q is odd. P square minus Q square is even. And you have the choices down here. Alright, before you solve this problem, there are little things that you have to be aware of. The first, and it's very important, is what exactly is a prime number. So you have to know what's a prime numbers, a set of prime numbers. You have to know what's an odd numbers. You have to know what's even numbers, right? Because in the question they said odd and even, right? So you have to be aware of this. Now the prime numbers would be 2, 3, 5, 7, 11, 13, and so on. Right? Yeah, it's here. And so on. Why these numbers, especially 2, 3, 5, 7, 11, 13, and so on? Alright, you have to know what is a prime number. A prime number is simply any number like 2, 3, or 5, any number that can only be divided by itself. It's divisible only by itself. Like, for example, 2 can be divided by 2, so that's a prime. 3 divided by 3, that's a prime. 5 divided by 5, that's a prime. Alright, what about 9? Is 9 a prime number? Someone might say, yeah, it is, because we divide by 9. No, it's not, because 9 is also divisible by what? By 3. So in this case, it's not only divisible by itself, it's also divisible by what? By another number, which is 3. So 9 is not a prime number. Also 1, note that 1 is not prime. Here in the list here, we don't have 1. So simply the prime numbers are the numbers that can only be divided by themselves. Alright? For the odd numbers, any number that cannot be divided by 2. It's very simple. As simple as that. Like 1, like 3, like 5, like 7, 6. Can we say 6? No. 6 can be divided by 2. Any number can be divided by 2 is not odd. So, and so on. What about even numbers? Even numbers are the numbers that can be divided by 2. Starting from 0, then we go on 2, 4, 6, 8. These are the sets of prime, odd, even. Of course, this is positive odd numbers, because I can write the same numbers here but with negative signs, like -1, -3, still odd. So I have to say this is positive even and positive odd. Alright? So now we know what's prime numbers, odd numbers, even numbers. Alright, now we go to the problem. They say if we have P and Q are primes greater than 2, which of the following must be true? Alright, they didn't say what are the values of P and Q. So here again we use what? I think you made a right guess. So it would be what? Plug in technique. Again, you can see that in many questions we're gonna use the plug-in technique. So you let P to be any value greater than 2. You can see here 2 is a prime. Anything greater than 2, we have 3, 5, whatever values. So I'm going to choose 3. And what about Q? Anything greater than 2 and 3. We have 5, 7, 11, whatever. I'm going to choose 5. So these are 2 primes greater than 2. Now let's check which of the following is true. P and Q is even. Second one, let's change it to bracket like that. Second one is P times Q is odd. And the third one is P square minus Q square is even. Alright, so we're going to substitute here. It's very simple. 3 plus 5. So I'm going to do 3 plus 5. 3 plus 5 is what? 8. Is 8 even? Ask yourself, can 8 be divided by 2? Yes, definitely yes. So that's even, correct. Great, so the first one is true. Is PQ is odd? P times Q, so we multiply. 3 times 5. What's 3 times 5? It's 15. Can 15 be divided by 2? No, definitely not. It's going to be 7.5. That's not an integer, so it can't. So this is odd. 15, check here. 15 belongs to which one of these? Odd or even? Odd, of course. Odd, of course. So the second one is true as well. Third one, it says P squared. So I have 3 power 2 minus 5 power 2 is even. Is it even? Okay, let's work it out. That would be 9 minus 25. We're talking about negative 16. As I said, negative doesn't make any problem here for me. Still even. 16 is even? Yes. Even with the negative sign? Yes, of course. It is even. All right, so this one is true as well. So all of them are true actually. All right, all of them. All right, check the answers. Do we have a choice that says all of them true? Yes, E here. I, double I, and 3. All of them are true. All of them are true. Must be true, yes. So the answer for this one is E. Right, I think it's simple. Great. All right, we move on to the next one. Here it says, which of the following is equal to 7 power 8 times 7 power 9, all raised to the power 10? So we need to do what here? We need to simplify this expression. And again, it's clear this is exponents. It means we have to use the laws of exponents. All right, let's see. So I'm going to write the expression here, 7 power 8 times 7 power 9, all raised to the power 10. All right, a good idea will be first multiply what inside the brackets. So we multiply inside the brackets, so multiply the 7 and the 7 here. Then we raise to the power 10. So first we work this one out. We work what inside the bracket out. So we have 7 power 8 times 7 power 9. This is which rule? This is rule number 1. Law, the first one. First law. Product of powers. It means I'm going to add the powers here. I'm going to add them. Right? All power 10. Alright. 8 plus 9, 17. So we have 17. We have 7 to the power 17, all raised to the power 10. Now, which rule should we use? It's very simple. If you check the rules, you will see that this is what? Power of a power. This is rule number 3. And rule number 3, what do we do? Very simple. We just remove the brackets and we multiply the powers. So it's going to be 17 times 10. You can do times like x like this one, doesn't matter, or just a dot. It's fine. Both are correct. So 17 times 10. So the answer is 7 to the power 17 times 10 is 170. Do we have 170 here? 7. Yes, here you go. All right. So the answer here is what? C. I think this one is very simple. All right. Hope you got that. All right. We move on to the next one. All right. In this question, it says if x greater than 0, less than 1, which of the following lists the numbers is in increasing order? Which of the following lists the numbers in increasing order? So we want x, it would be some value between 0 and 1, and we want an increasing order. Which of the following lists the numbers in increasing order? Again, the plug-in technique. Now you can see why this technique is very important. All right. So again, the plug-in technique. Let x any value between 0 or 1. Anything. All right. I'm going to choose 0.5. Now, we have x squared, and radical x. So a good idea is to write, all right, x squared in any order, doesn't matter, any order, okay, and substitute. So we have here 0.5, 0.5 power 2, and radical 0.5. Okay, simplify it further. This is going to be 0.5. This is going to be 0.25. You can work it out on the calculator. And this one, if you do it on the calculator, it's 0.707. Now put them in order. Can you do that? All right. Ascendingly. Ascendingly means increasing, in an increasing order. Starting from the least, that would be this one. All right. So it's going to be 0.25. That would be the x squared. And then comes the 0.5. That would be x. Then comes what? 0.7. All right. In ascending order. It's this way. We have the radical. So in increasing order or ascending order, we have x first and then x and then radical x. Do we have this? Yeah. Yes, definitely yes. We have x squared, x and radical x. See? Here you go. B. Very simple. Okay, maybe it takes less than 1 minute to solve a question like this one. Okay, if you know how to use the plug-in technique. Okay, it's very simple one. All right, now to the next question. We have, what is the value of absolute? This is an absolute problem. It says, what's the absolute of -2 minus 4 minus 2 minus 4? You can see that. All right, it's always a good idea to work out any bracket in the problem. Like here, I'm going to write it again. All right, this is -2 minus 4. I have minus here, 2 minus 4. So first step, work the brackets out. This one, simplify it. -2 minus 4, that's -6. 2 minus 4, that's -2. Keep the absolute and then simplify this one. So we have -6 here. Here, minus minus, change to positive, right? Negative times negative is positive, so this is +2. Simplify further. So this is going to be -6. All right, -6 plus 2. What's -6 plus 2? -4. Very simple. Apply the rule for the absolute now. We have a negative, dirty clothes. In the washing machine, it comes out what? Comes clean, comes positive. Clean, all right? So the value is 4. So I think now you've got a good understanding of the plug-in technique. And if you keep those concepts in your head, I think it will help a lot. Also, you know, in order for you to obtain the maximum benefit out of this tutorial, I would actually advise that you work out all the problems we have addressed in this video. So what I want you to do is to solve all the problems again by writing. Okay, you bring your copybook, a notebook, and pen or pencil, whatever, and you write them down, the answers. You know, after all, writing anything down makes us remember it better. I'm Bassem Khalid, and you are watching Teach Me Sat. Thank you for viewing.